All right. What we're looking at this time is that we're looking at a question 1 from the 2019 January CXC Paper 2. So it says 3 point, I'm reading here. It says 3.8 times 10 to the second plus 1.7 times 10 to the third, giving your answer in standard form. With a question like this, what we want to do is just take our time to find out what this part is and what this part is, put it together, and then give our answer in standard form. All right, so let us go. 3.8 times 10 to the second really means times 100 plus 1.7 times 10 to the third really means 1,000. So if we do this, we would have gotten 380 plus 1,700. 1,700 plus 380, that's going to give us a total of 2,080. But remember that our answer must be represented in standard form. Remember that standard form is written in the form A times 10 raised to the n, where A is a number less than 10, but greater than or equal to 1. So we have to write it in that form, and n is an integer. All right, so n would represent an integer, which means that it could be a negative number, a positive number, or 0. No decimals or no fractions for the power of n. So here it is that we go then. So it means that we want to make sure that the decimal point comes immediately after the first non-zero digit. So we want to get the decimal point right there. So in standard form, it's going to be 2.080 times 10. And then we want to just check ourselves to see how many places we had moved the decimal point in order to get it here. So it would have moved 1, 2, 3 places. So it's 10 to the third. All right. And then what we want to do is if the number that we started with is greater than or equal to 1, it's a positive power. And if it were less than 1, that means a 0 point something number, it would have been a negative. So this is the answer that we're looking for. All right, so the question says, give your answer as a fraction in its lowest term. So then what we want to do is that we're gonna work this out, give our answer as a fraction. So I'm gonna work on the top part, right? Remember though that what I normally do is to convert my mixed numbers into improper fractions. And how we do that, we multiply the denominator times the whole number, and then we add that result to the numerator. So 2, 3, 6 plus 1, 7. So this is 7 half for the bottom part here. So let's work out the top part first. So I'm going to work out this part first. I have half times 3/5. Remember when you're multiplying fractions, the numerator multiplied by the numerator and the denominator multiplied by the denominator. As long as there is nothing to be canceled, I normally just go ahead and do that early. So we're looking at 3 times 1, 3 over 10. So this is the response from the top. So then it's 3/10 that must be divided by 7 half. We follow through, it's going to be 3/10 times 2/7. Remember, whenever we're dividing, we change division to multiplication, and then we reciprocate the fraction that comes after, right? So the last fraction, we flip it upside down. So what we're looking at here is 2 into itself, 1 time, 2 into 10, 5. Final results, 3 times 1, 3. 5 times 7, 35. So our response for that is 3 over 35. All right. All right. So what we have here is that we intend to express the number 6 in binary. All right. And binary refers to base 2. Normally, when you're moving from base 10 to base 2, you divide throughout by the base and you keep the remainder. So then we can just easily rule up a little column like this, little column like this. So we're going to be dividing, yes, by 2, and we want to keep the remainder here. When we get the remainders at the end of the day, we're going to read upwards. So let's divide and keep the remainders. So 2 into 6 goes 3 times and a remainder 0. 2 into 3 goes 1 time and remainder 1. But 2 into 1 we can't, so we're going to put back the 1. Then we're going to read our answer upward. 6 from base 10 is equal to 110 in base 2. All right, so this question says, John bought a car for $65,000. If the value of the car depreciates at 8% each year, how much will the car be worth at the end of 2 years? Well, we can work through this using a formula, or we could go about doing this by using the reducing balance over 2 years. Let us say that we wanted to approach it using the reducing balance. The car is going to depreciate at 8% every year. So then there is a depreciated value at the end of that year. And then we would have to reduce the original principal, which is the $65,000, by that depreciated amount in order to get a new balance for the next year. So let us go with year 1. So this is year 1. And this I'm going to be working on is the depreciated value. So I'm going to find how much it's going to be depreciating by. So it's going to be 8%. 8% is 8 over 100, and it is of $65,000. So let us try not to make any error. 8 divided by 100 times 65,000. This is going to be 5,200, which means that in the first year, 5,200 would have come off. Now let's look at the new balance going into year 2. So then it's going to be 65,000 minus 5,200. So then 65,000 minus 5,200 is going to give us $59,800. So this is our new balance going into year 2. So let us write it there. So then in year 2, we're still going to be depreciating by 8%, but now we have a new balance of 59,800. 8% of this will give us 4,784. So this is the amount that is being taken off the second year. So remember that the new balance was 59,800. Now we're going to take off 4,784. So let us subtract this. After we do that, we end up with $55,016. So $55,016 is the amount that is left after 2 years being depreciated at 8% per annum. A method 2 that we could have employed to get that same thing. We can find the total at the end of the period by using this. So the balance at the end is equal to our principal times 1 minus 8 over 100. And this is going to be raised to the second power because it's 2 years. And this is the 8 for the 8% that we're setting up. So this is the formula. The formula really reads P, open bracket 1, minus R over 100 raised to the N, where R refers to the rate percent, which is the 8%, and N refers to the years. Let's walk ourselves through this. So basically, we're going to have 65,000 here times 1 minus 0.08, yes, square, which is going to take us to 65,000 times, and let us just do that, we'll get 0.92 square. So let's put this on our calculator, 0.92 square times 65,000, and we should still see the same answer as $55,016, just like what we did there. Let us finally go on the last question at number 1 for that year. It says below shows the results obtained by a student in her CXC mathematics examination. The maximum mark for each paper is given in the third column of the table. So these are our max. Papers are being marked out of 30, out of 50, out of 20. And then finally, out of everything, we see 100. So what this is saying then, the percentage obtained out of that 30 was a 55, and then out of 50 was 60, and out of 20 was 80. So we could definitely, there are a number of ways we could work this out. So what we can do here is look what the question wants. Determine as a percentage the student final mark for the exam. Now, percentage is out of 100. So as long as I find the value here and add it, it will be as a percentage because it's from a total of 100 already. So basically, we want to find 55% of 30 because we have 0.55. So that's 55%, which is a 0.55 times 30. Remember, 55% means 55 over 100, and that is how we got the 0.55 there. We multiply that by 30, we get 16.5. If we work out 60% of 50, all right, work out 60% of 50, that is 0.6 times 50, we get 30. And if we work 80% of 20, 0.8 times 20, we get 16. So then what we need to do is to add everything up. We're talking 16.5, let me put it here, 16.5 plus 30 plus 16. We add that all up, we'll get 62.5%. So person would have gotten 62.5% on the exam. And there you would have collected your 2 marks there. All right. Thank you for watching. Please like, subscribe, drop a comment, and share Daily Maths Concepts. Bye-bye.